If we have two wave sources, each creating waves that are going to overlap, we know that we're going to have some interference, some superposition going on with these two waves that are created. So, for example, if we pulse or if we create two waves using this is a wave simulator created by PhET out of University of Colorado, we can see that the two ripples created by these two drops of water, they cross paths at this point. And so if we have a low point from one wave and a low point from the other wave at the same place at the same time, then we get a really low point. If we have two high points, then we get a really high point. So I think the lighter area is supposed to represent higher points, the dark area is supposed to represent lower points. And we can also understand, how low and how high those are based on the values that are shown here. Now this is just for along this dotted line, so sort of limited usefulness there. We don't really have a three-dimensional representation of this. If we have these waves just constantly being created, and it's a little laggy here, but if we have these constantly being created, with each wave or each sink in this case creating waves with a similar frequency, we start to see this pattern arise where this area right here, kind of this grayish area or medium darkness area in the blue anyway, and here and here, those are areas where our waves are always adding together destructively. So we have a high point for one wave and a low point for another wave, and so those kind of cancel each other out. And then in between those, here and here and here and here, we see that we have really dark and really light areas alternating. We get very, very deep and tall ripples. And so that happens when our waves are adding together constructively. So what determines where these different areas are? How come everything along this line we have destructive interference and everything along this line we have constructive interference? How do we relate that? And what factors influence it? Like what if we change the frequency, increase the frequency? So like right here a second ago it was an area of destructive interference. And we can see now that that's kind of on the border now between destructive and constructive interference. Now we've got extra of these gray lines, these destructive interference lines. And if we go really high frequency, we'll see another change there. So now we've got even more of these little gray areas, and they're really narrow gray areas there. So what is it that determines where those destructive interference areas and where the constructive interference areas are going to show up? Well, it turns out it's going to be a combination of the wavelength of each wave and the distance from each source.